Really, in our lungs, the HHGB reacts with O2 and forms the HHGBO2. And once this forms, what happens? Okay, so I hate to do it, but I guess I have to. Okay, so there's you. There's your lungs. So here's the air. We're going to inhale the air, and we know that air has O2 and nitrogen in there. So now we have O2 in our lungs. Then you just said that the O2 reacts with the HHGB, and now we have the HHGBO2. This is supposed to be our blood, okay? So where does that go? That goes to your toes down here, okay, your feet. It goes all the way down there. And what happens in your cells in our body? So the HHGBO2 is transported through our blood to where? Yeah, our cells, our tissues. Okay, so, and the next question, in the tissues, is the conjugate acid or conjugate base of hemoglobin formed? Okay, so let's go back to our picture. So, again, the HHGB binds the oxygen in our lungs to form the HHGBO2. The HHGBO2 has a pKa of 6.2. Okay, so getting back to our picture, so this is for the HGB, and then for the HHGBO2, what does our titration curve look for this one? So it's going to look, in other words, how is the titration curve for this one going to differ from this one? Yes, the only difference is going to be, the halfway point. So we'll draw another titration because the halfway point here is 6.2. Our pH of blood is 7.4. So is there going to be more of the conjugate base form present or the acid form present? Yeah. So at this point here, are we going to have more base or more acid present? More base, which means if you go back to our picture, note that we're going to have more of this form present in our tissues than that form. Okay, so again, in our lungs, the HHGB binds the oxygen form HHGBO2, gets transported through our blood to our tissues. In our tissues, this is going to be the form of hemoglobin present. Now, what happens in our tissues? Once this hemoglobin gets to our tissues, what's it do with the oxygen? It's got to release the oxygen. So when the oxygen is released here, that means we're effectively doing what? Are we adding or removing oxygen here? We're actually removing it. So if we remove, because the O2's got to react with the food, and that provides energy. So when that happens, in which direction does this equilibrium reaction shift? Does it go toward the HGBO2 or toward the HGB? It's going to go toward the HGB. Okay, because again, the O2 is being removed because that's going to react with the food to form energy. And as this is removed, the reaction is shift toward the HGB. Okay. And then once the HGB is formed, since, as we just discussed, the pH of our blood is 7.4, we want to find more of the acid present in the base. Okay, so once the HGB is formed, it's going to form the HGB, the conjugate acid form. Okay, so let's go back to that question again. So again, in the tissues is the conjugate acid, the conjugate base of hemoglobin form. So we said that it's going to be the conjugate base form. In part D, when when O2 is released, which equilibrium reaction is affected? In which direction does this reaction shift? So we said that when O2 is released in our tissues, the equilibrium reaction which is affected is? Is this one the HGB plus O2 going to the HGBO2? And finally, how does eating replenish HCO3 minus in our blood? What other effect does eating have on the buffering action of hemoglobin? So what does eating do? Besides make you feel good, depending what you eat. Yeah, so eating will produce CO2 and H2O. That's going to replenish the HCO3 minus. But what else is that going to do? That's going to provide a proton, and that proton is going to do what? React with the HGB, and that's going to form the HGB, and that goes back to our lungs, and it starts all over again. So it's like that they say, it's that one big circle. It's like a wheel. You're like the hamster on the wheels. Producing all that energy. Doing all that stuff. Okay, so on Wednesday in class, what we'll talk about. Yeah, so on Wednesday in class, what we'll talk about. On Thursday in class, we'll look at some more about solubility. This goes all the way back to Chem1A solubility about insoluble compounds. Then we'll learn how to dissolve these insoluble compounds. And then we'll look at some hard water. And we'll look at these complex ions. And then we'll have our spring break. Okay, so I'll see you guys in lab later on today.